All right, we're going to talk about monotonic functions and the first derivative test. So a function that is increasing or decreasing on an interval is said to be monotonic on the interval. So what we're looking at is we're looking at an interval on which the function is always increasing or always decreasing. That's what monotonic means. So corollary 3, suppose that f is continuous on the closed interval a to b and differentiable on the interval, open interval a to b. If f prime is greater than 0 at each point in that interval, then f is increasing on the closed interval. Okay? If f prime is less than 0 at each point of element of the interval, then f is decreasing on the closed interval. Okay? So what this is saying is that if my derivative, remember derivative finds slope. So if my slope is positive, I'm increasing. If my slope is negative, I'm decreasing. So here we have f of x. F of x equals x cubed minus 12x minus 15. The first thing I need to do is find my derivative. So 3x squared minus 12. I'm going to split that up. I need to find my critical points. Remember, my critical points are where the derivative is undefined, where the derivative equals 0, and my endpoints. Well, I don't have any endpoints in here. So now what I need to do is I need to find the critical points where that derivative is 0. Well, the derivative is going to be 0 at -2 and 2. So what that does is that allows me to find my intervals now. Okay? So I'm going to find my intervals. So I'm going to go negative infinity to -2, -2 to 2, 2 to infinity. Those are my intervals at which this function is either going to be increasing, decreasing, or constant. Now, the way I test this is I go back and I look at my derivative. What I'm going to do is I'm going to pick a value inside this interval because any value, whatever I pick in here, whatever its sign is, all the values in that interval has to be the same sign. So if I picked here, if I picked -10 and I found it was positive, -11 would also give me a positive value there. So I'm really looking at when I pick a value here, is it going to give me a positive derivative or a negative derivative? That's really all I'm looking at. So pick a value between negative infinity, -2. Let's just say I pick -3, so this is 3, -3 plus 2, -3 times -2. So this positive, I don't have to worry about that. This is going to be negative and negative. Negative times a negative is positive, so this is going to be increasing. Okay? So I didn't actually find the value, I just found the sign of it. I only need to know if it's increasing or decreasing. So this gave me a positive value because negative times a negative is positive, increasing. I have to pick a number between -2 and 2. I pick 0. So this is positive, this is negative. Positive times a negative is a negative or decreasing. Okay? Now I pick something between 2 and infinity. Let's pick 10. Positive, positive. So I have a positive times a positive times a positive. That gives me a positive or increasing. So this graph is going to be increasing from negative infinity up to -2, at which point the slope is 0, right? It's going to be increasing there. It's going to be decreasing down from -2 to 2, and then increasing again at 2 to infinity. Right? So we're trying to find those areas where the function is increasing or decreasing. So our next one, we're going to do the same thing. I've kind of written out the derivative just to kind of save some time here. So f of x equals the quantity x squared minus 3 times e to the x. I'm going to use the product rule. Okay? So the derivative of x squared minus 3 is 2x times e to the x, plus now I have to take the derivative of e to the x. Derivative of e to the x is e to the x, so I have x squared minus 3 times e to the x. They both have an e to the x, so I'm going to factor that out, giving me e to the x times the quantity x squared plus 2x minus 3. I'm going to factor this into e to the x equals x plus 3 times x minus 1. Okay? Now, I would actually want to take each of these and set it equal to 0. Well, e to the x is never equal to 0, so I don't have to worry about that. So my critical points are -3 and +1. So now I'm going to put in my intervals. Negative infinity to -3, -3 to 1, 1 to infinity. There can be So we're always going to have, depending on our critical points, one more than our critical points. I have to pick a value here for between negative infinity and negative 3 to see if it's going to be positive or negative. Well, the nice thing is e to the x is always positive, right? It actually cannot be negative unless I multiply it by a negative. So I actually don't have to worry about that so much. That's going to be positive. So let's pick negative 4. If I pick negative 4, I get negative, negative, positive. Positive times a negative is positive. So this is positive, this is increasing. Okay, so if you didn't see what I did there, I went e to the negative 4 times negative 4 plus 3, negative 4 minus 1. Okay, so that gives me e to the negative 4 times negative 1 times negative 5, which gives me 5 e to the negative 4th. Well, e to the negative 4th is just a small number. It's still positive, so that's a positive number. So now I'm going to pick something between negative 3 and 0, or sorry, negative 3 and 1. I'm going to pick 0. So that gives me positive negative, which is negative. So this is decreasing. Okay. I'm going to pick something between 1 and infinity. 5 is fine. Positive, positive. That gives me positive. This is increasing. So what we're really looking at in this section is finding those intervals at which it is increasing and decreasing, using our derivative, using those critical points, and then using our derivative to find out the slope within that interval, whether it's positive or negative, to determine whether it's increasing or decreasing.